Hi, today's lesson will be about distance time graphs, which follows on from the previous lesson, which was about speed, where you will have covered the equation speed equals distance divided by time. Okay, so by the end of the lesson, we will again recall the equation for speed, which is distance divided by time, look at an example of distance time graph, and analyze different aspects of a distance time graph. So a distance time graph displays distance against time. On the y-axis we have distance, and on the x-axis we have time. And on a distance time graph we usually have three different types of lines. We have a straight line, a line going upwards, and a line going downwards. So what do these lines actually mean? If we have a horizontal straight line, like for example between 20 and 40 seconds, that tells us the object is stationary and is not moving, because as the time increases, the distance has not changed. The object was at 10 meters. After 20 seconds, it is still at 10 meters. Now a line going upwards tells us the object is moving forward, but at constant speed. For example, between 0 and 20 seconds, the object has moved to 10 meters at constant speed. And a line going downwards, like for example between 60 and 100 seconds, that tells us the object is moving at constant speed, but back to the start. Now if you look at the two lines between 0 and 20 seconds and 40 and 60 seconds, you will notice that the line between 40 and 60 seconds is more steeper. Now that tells us that the object is moving quicker during this time interval. So the steeper the line is, the quicker the object is moving. What I want you to do now is to describe the movement of this object as it goes through each 20-second time interval. So you can pause the video and answer the 4 questions on the right hand side. Okay, so between 0 and 20 seconds, because the line is going upwards, we know that the object is moving at constant speed. Between 20 and 40 seconds, we can see there is a horizontal line. That tells us the object is stationary as the distance has not increased. And between 40 and 60 seconds, again, it's a line going upwards, but it is a steeper line. So it tells us the object is moving quicker. Again, it is traveling at constant speed. And between 60 to 100, we know the object is moving at constant speed because again it is a straight line, but it's going back to the start as the distance decreases from 40 to 0 meters. On the previous slide, we were describing the movement of the object through a distance time graph. However, sometimes on a distance time graph, you might get asked to describe the distance time graph through numerical values. For example, how far had the object gone after 20 seconds? So what you need to do is look on the distance time graph, go to the time axis and go across 20 seconds and then go up until you meet the line. And we can see that the object has moved 10 meters simply by going across the x-axis and then up the y-axis. For question number 2, how far had the object gone after 60 seconds? So again, you start at 0, go across the x-axis, till you get to 60 seconds, and then you go up until you meet the red line at the top, which tells us the object has moved 40 meters after 60 seconds. Now looking at the whole distance time graph, for question number 3, it's asking us when is the object standing still. So what we need to do is look at the distance time graph to see if we can see any horizontal line. And we can see that there's a horizontal line between 20 and 40 seconds, which tells us the object is stationary between this time interval. Now a question that we haven't done yet is calculating speed on a distance time graph. We know that speed equals distance divided by time. So how can we calculate the speed of an object between a time interval. So if you look at the challenge question, it says calculate the speed of the object between 40 and 60 seconds. So the first thing you need to do is draw a triangle between 40 and 60 seconds. So we are going to calculate the speed between 40 and 60 seconds. Once we have drawn the triangle, we then need to work out the time interval and the distance covered in this time interval. So if we start at 40 seconds and go across to 60 seconds, we know that it has taken 20 seconds to cover this distance. And the distance covered between 40 and 60 seconds, we start at 10 meters, if you look at the y-axis, and go right to the top. We can see that it ends at 40 meters. So distance covered is 40, take away 10, which is 30 meters. Now if we now place these numerical values into our equation, where we said speed equals distance divided by time, to calculate the speed, we simply do 30 divided by 20, which tells us that the speed during this time interval, the object was moving at 1.5 meters per second. Don't forget, when you're calculating speed or distance or time, you need to make sure that you have the correct units after your answer. Now, task 2, we're going to look at drawing a distance time graph. For example, we have a car here, and we're going to look at how this car moves. And later on we'll see if we can annotate the movement of this car on a distance time graph. So if you watch it firstly, and for the second time I will take it back and I'll describe how the car is moving. So let's look at the movement of the car during its journey. At the start the car was stationary, it then moved slowly, then it moved quickly, it was then stationary for a second time, it moved slowly for a second time, and it was then stationary for a third time. So how would we draw a graph for the journey of this car? So the graph would look something like this. At the start, the car was stationary for a second or two. It then moved at constant speed, slowly. The car then moved quickly, and we can see that on the graph because the line is steeper. The car was stationary again for a second. Again, we represent with a horizontal line. The car then moves slowly for a second time, which we can see with a shallow line, and the car was stationary for a third time. So this is how we would look at some numerical values or movement of object and illustrate a distance time graph. Again, we can analyze distance time graph by looking at the lines. Remember, a horizontal line tells us the object is stationary. A line going upwards means the object is moving at constant speed. If we had a line going downwards, that would tell us that the object is moving at constant speed, but back to the start. If we were asked to calculate the speed, we would simply draw a triangle, work out the time interval, then work out the distance interval, and divide distance divided by time to tell us the speed during that time interval. What I would like you to do now is to draw a distance time graph for both of these data tables on this slide. Remember, the distance axis is always on the y-axis and the time is always on the x-axis. And make sure that for every square box you go by the same amount for each time interval or distance.